Today we're doing double angle formulas, so I'll write that on top for you. Double angle formulas. So this is the next phase of the formulas we're working with. For now, our goal is to figure out what is sine of 2 theta and what is cosine of 2 theta. So first, let's actually derive them. If you think about sine of 2 theta, that's the same thing as saying sine of theta plus theta. Now what we're going to do is think of this as like alpha and beta, like how we were doing in or how we're working with our sum and difference formulas. So let's write that out. Sine alpha, or theta, cosine beta, which is theta, plus cosine alpha, and then sine beta. So notice how they all line up, and notice how they're both equal, which means we can condense that to 2 sine theta cosine theta. So right there, we actually just derived it. That is 2 sine theta cosine theta. Now you don't have to know the derivation, but it is helpful to know that on a test or quiz, so that way you can just derive it, because all of you should have the sum formula memorized by now. So for cosine, let's try it. I'll do that in blue for you. Cosine of 2 theta, that's cosine of theta plus theta. So that's going to be cosine theta minus sine theta. So we simplify. That's cosine squared theta minus sine squared theta. So there we go. There is our cosine formula. Okay, now the cosine was actually unique. There are 2 more versions of it. There is a 1 minus 2 sine squared theta, and there's a 2 cosine squared theta minus 1. Now those are all equivalent, and if you're wondering where that came from, just remember this note, cosine squared is equal to 1 minus sine squared, and sine squared is 1 minus cosine squared. So just remember that on the side, and that should make it more apparent as to why the other forms exist. Okay, so far, those are the formulas. Now you'll notice that these are actually a lot easier than the problems we did last class, because if you look at that first question, sine theta is 3 over 5, theta is between pi over 2 and pi. We obviously know we got to draw a triangle, but notice how there's only one triangle. That's pretty convenient. That would mean the triangle is in quadrant 2, so let's just draw that out. The opposite is 3, hypotenuse is 5, that makes that -4, let's call that theta. To figure out sine of 2 theta, look at the formula. 2 sine theta cosine theta. Plug it in. 2 sine theta is 3 over 5. Cosine theta, -4 over 5. Multiply, -24 over 25. So look how easy that was, no problem. Cosine 2 theta. I recommend memorizing the first one, cosine squared minus sine squared, because it's pretty easy to derive the other two if you were to need them using this main one. And now I just figured it out. Cosine theta, that's -4 over 5. We're going to square that. Minus sine theta, which is 3 over 5, square that. That's 16 over 25 minus 9 over 25, which is 7 over 25. Done. And there it is. Okay, we'll get to part C in a little bit. Before that, it says establishing identities is figure out tan 2 theta. So over here, let's just write this tan theta plus theta. So let's write out tan theta plus tan theta, all divided by 1 minus tan theta times tan theta. Now, if you're wondering how I did that, just recall tan A plus B, that's simply tan A plus tan B all over 1 minus tan A times tan B. Now we simplify, that's simply 2 tan theta over 1 minus tan squared theta. And there it is. So now let's try that formula on the final part. So the formula for C, and I recommend you guys write the formulas each time because that way helps you remember them. 2 tan theta over 1 minus tan squared. So that's going to be 2. Tan theta is 3 over negative 4, or negative 3/4. And then divide that by 1 minus 3 over negative 4 squared. Okay, now when you're working on this, I really want you guys to highlight. Make sure you start working right here. That way it'll minimize your error. So the top, don't worry about that. The bottom, 1 minus, let's square that. That's positive 9 over 16. And the top, we can reduce that now. That crosses out, so that's 3 over, or negative 3 over 2. Okay, now once you have a complex fraction, I recommend you get rid of all the complex fractions. So multiply by the common denominator, which is just 16 over 16. So now we get negative 24 all over 16 minus 9, which leads us to the answer, which is negative 24 over 7. And there it is. Now, the one thing we could have done to make this a lot simpler, and you could do this on your homework or test or quiz, is notice how we actually knew sine of 2 theta, cosine 2 theta, which means think about tangent. Tangent of 2 theta must be equal to sine of 2 theta over cosine of 2 theta. So let's plug it in. Negative 24 over 25 over 7 over 25. Look at that. You get the exact same answer. Now finish the next part of the worksheet and watch the rest of the video once you are ready. Today we're covering half angle formulas. And this is the last major formulas we'll do for this particular section. Notice how there are 3 of them. 1, 2, 3. The sine and cosine ones look pretty similar. And then the tan one is obviously does not look the same. But what's weird about this is you see that plus or minus. That's the first time we've really seen a plus or minus in one formula. So I'm going to put a star to indicate how to work with that. So the plus or minus depends on the quadrant of theta over 2. Okay, so that's really important to write down, that the plus or minus will depend on the quadrant of your half angle. And then one more thing to add is notice how sine and cosine, they're pretty much the exact same formula. The only difference is this negative. So something a student told me a long time ago that helped me remember was they called this one sad sine, because sad meaning negative. Now, that's of course purely a memory trick, but I found it does help, so you can try that out. So for deriving these, I'm going to have you guys do it. So we're just going to go straight into using the formulas. Let's start with the first example, cosine 15 degrees. So the first thing I'm going to do is note that 15 degrees is in quadrant 1. So if we were to write the formula out, we know that cosine theta over 2, that's plus or minus the square root 1 plus cosine theta over 2. In the beginning, it's important to write that because it'll help you remember what to do. The reason I told you it's quadrant 1 is because think about cosine in quadrant 1. All of those values are positive, so let's get rid of that negative there. So that tells you which one it would be, plus or negative. In this case, it's positive since we're in quadrant 1. Now what you want to do is focus on this 15 degrees. So I'll highlight this for you. We want to rewrite 15 degrees as something over 2. So quickly think in your head, that would be 30 over 2. That's 15. Now the reason we do that is because now we can evaluate. That's 1 plus cosine 30 using the formula, all over 2. Cosine 30 is something we know. Cosine 30 is root 3 over 2, all divided by 2. We're going to multiply top and bottom by 2 over 2 to clear the complex fraction. And now we have 2 plus root 3 over 4. Now in most cases we'd stop there, but since the denominator is such a nice number, we're going to take the square root of 4. So we're going to make it 2 plus root 3 all over 2. So notice how you have a radical and a radical. That's okay. And the bottom, we just made that 2 since the root of 4 is 2. So we'll stop right there. Now had that 4 been like a 10, in that case we'd stop there. I'm not going to have you go any further. I only went further since 4 is a really nice number. Next one. Sine of negative 15 degrees. So a lot of ways you could do this. I'm going to say let's use our odd property. Let's grab that negative and pull it out right there. So that's negative sine 15 degrees. So we know the formula. That's going to be sine theta over 2 plus or minus the square root of 1 minus cosine, remember sad sign, all over 2. Let's carry that negative. So sine of 15 degrees, I'm going to write that as sine of 30 over 2. So now carry the negative. Let's work it down. 15 degrees. So now we're at that point, right? Is it positive or is it negative? 15 degrees in quadrant 1, which means the value should be positive. So we know it's a positive root. So I'll write positive root 1 minus cosine 30 all over 2. Positive root, so no need that anymore. Let's just keep going. So negative bracket, big root, 1 minus cosine 30 is root 3 over 2. That's all over 2. At this point, let's kind of clean our work up. We don't need these brackets. And let's multiply top and bottom by 2 over 2. And notice that's pretty much the same thing we just did, just negative. So negative root 2 minus root 3 all over 2. So I simplify that step because it's the same as last problem. There would be a 4 on the denominator, but we just take the root of that. So now we have that as our answer. Okay, tan problem. So the tan problem over here, this one's going to be a little tricky. The good thing about the tan formula is if you think about the actual half angle formula, tan theta over 2, that's going to be 1 minus cosine theta over sine theta. Notice how there is no plus or minus. So this formula is great because you don't worry about the quadrant at all. You can just straight plug it in. The challenge will be, how do you rewrite this angle as something over 2? So notice how earlier on the 15 degrees, it became 30 over 2, which means you just multiply it by 2. So 3 pi over 4, or 3 pi over 8 times 2 is just 3 pi over 4. So you write it as 3 pi over 4 over 2. And notice how that is 3 pi over 8. Now we have 1 minus cosine 3 pi over 4 over sine 3 pi over 4. That's 1 minus negative root 2 over 2 divided by root 2 over 2. And now we just got to do a little bit of algebra. This is 1 plus root 2 over 2 over root 2 over 2. Now we're going to get rid of the complex fractions. Let's multiply by 2 over 2. So that would be 2 plus root 2 over root 2. Now let's finish it up. Let's rationalize this to make it a little cleaner. Multiply by root 2 over root 2. So that's 2 root 2 plus 2 over 2, which finally reduces to root 2 plus 1. So a little heavy algebra there, but there's our answer, root 2 plus 1. Now let's go to our last example. Hopefully if you look at this setup, you can immediately recognize what you have to do. You have to draw a triangle. So if you look at this right here, that tells you what quadrant you'll be in. That tells you you're in quadrant 3. So what we're going to do first is let's just draw that triangle out. So there's my y-axis, x-axis, a triangle in quadrant 3, -3, 5, that makes us -4, and there is alpha. Okay, so there is our alpha triangle. So now let's try A. It says sine of alpha over 2. So let's write the formula. Plus or minus the square root 1 minus cosine alpha all over 2. Now it looks pretty easy, right? Let's plug it in. The real issue is this plus or minus. How do we know if it's plus or minus? Which one is it? What you have to do is look right here. It's all about the quadrant of this thing. Alpha over 2 is in what quadrant? Now, what's important to know is alpha is in quadrant 3. Okay, so alpha is going to quadrant 3. What we don't know is alpha over 2. So to do this on the side, I'm going to give you a little diagram. You have to understand that with half angles, this is for triangle problems. Triangle problems. There's a little trick we have to use. If this is theta, and this is theta over 2, so think about a quadrant 1 angle, like let's say 45 degrees. If you half it, notice how you're still in quadrant 1. Now if you're in quadrant 2, let's pick a quadrant 2 angle, like let's say 120. If you half 120, you get 60. So notice how you're still in quadrant 1. So far that makes sense. Now quadrant 3 and quadrant 4 is where it gets a little bit counterintuitive. If I pick a nice quadrant 3 angle, let's say I pick 240, if I half it I get 120, which is in quadrant 2. And quadrant 4, let's say I pick 300, if I half that I get 150, and look, that is also in quadrant 2. So notice right here, for these triangle problems, when you half it, it's always going to be quadrant 1 or quadrant 2. So if you look here, let's go back to our problem right here. If alpha is in quadrant 3, look at your chart, that makes alpha over 2 in quadrant 2. So that's your true quadrant for this particular problem, which means we erase a negative. Sine is positive in quadrant 2. So now we're going to keep going. We know it's positive, so the root 1 minus cosine alpha, which is -3/5, all over 2. Now we just got to do a little bit of fraction work. Let's make that 1 plus 3/5. Let's multiply by 5 over 5. So you have the root, that's just 5 plus 3 over 10. That would be 8 over 10, which is 4 over 5. And that becomes, through a little bit of rationalization, 2 over root 5, which is 2 root 5 over 5. So there we go. So now we go to B. Let's write it out. Plus or minus square root 1 plus cosine alpha all over 2. Remember, this is in quadrant 2. So cosine, the x, those values are negative. So let's really highlight that negative here. So we have negative root 1 plus cosine alpha is -3/5 all over 2. And now let's take the same thing we just did. Multiply by 5 over 5. That's just 5 minus 3 over 10. So that's 2 over 10, which is 1/5. So negative root of a fifth, which is simply negative root 5 over 5. Done. Now the last one, tan alpha over 2, we can just use a formula. That's just 1 minus cosine alpha over sine alpha. Again, tan's the best one because there are no plus or minuses anywhere. You straight up use a formula. So 1 minus cosine alpha, which is -3/5, all over sine alpha, which is negative 4/5. Let's simplify that a little bit. That's just 1 plus 3/5. I'm going to multiply everything by 5/5. So that's just 5 plus 3 over negative 4, which is 8 over negative 4, which is negative 2. There you go. Now notice how we also could have made that a lot easier, how we just divided part A over part B. You also get negative 2. And that's because sine over cosine, that is, of course, 10. So here's our final example. I put practice quiz question, but it's more just to show you like a higher level thinking kind of question. So first, we have to understand that this thing right here, that's a theta. So the question is really, what is secant of 2 theta? So if you have a question like this, remember that you just draw a triangle. So let's put a triangle right here. Theta right there. Recall that tan inverse is quadrants 1 and 4. So that's how I know it's in quadrant 1, because this thing right here is positive 3/4. Fill that in as 3, 4. We should know that hypotenuse is 5. And now, look, we can figure this out. Now, you got to know secant 2 theta. That's simply 1 over cosine 2 theta. And 1 over cosine 2 theta, let's expand that. We now know cosine 2 theta, that's cosine squared minus sine squared. So let's take 1 over cosine theta is 4/5 squared minus sine theta is 3/5 squared. That's 1 over 16/25 minus 9/25. That's 1 over 7/25. Final answer is 25/7. And we are done.